Good morning, students. Today's topic in chemistry subject is simple molecular structure. So concentrate yourself. Again, very important topic, and we are going to start now. You already know about covalent bonds are strong. So have you ever wondered why lots of the substances with covalent bonds are easy to melt or boil? Let's take methane CH4 as an example. It has very low boiling point. It boils at minus 161 degrees C. Compare this with the values given for the giant covalent structures in the table below. Diamond, boiling point is 4830 degrees C. Silicon 2353. Sand is also 2000 plus degrees C. Whereas methane boil at minus 164, water 100 and chlorine minus 35. These are the giant molecular structures. These are simple molecular structures. So why there is a lot of difference? By the time you get to the room temperature, about 20 degrees C, methane is already a gas. And yet it has strong covalent bonds holding its atoms together, just like diamond. So why is it so easy to boil methane? Now concentrate, very important question. To answer this question, you must realize that no covalent bonds are broken when methane boils. Very important point. No covalent bonds are broken. When it boils, single CH4 molecules move apart. They separate from each other, but they are still CH4 molecules. And this is the diagram representing the breakaway of the methane. Weak forces between the molecules. Strong covalent bonds within each molecule. Methane has a simple molecular structure. Substances with low melting points and boiling points have simple molecular structure. Remember this point. They have strong covalent bonds joining their atoms within each molecule. However, they only have weak forces between individual molecules. We say that they have weak intermolecular bonds. Iodine, I2, has a simple molecular structure. Weak forces hold its molecules in place in its crystal. Sulfur exists as S8 molecules at room temperature. These crown-shaped molecules are packed neatly together to form crystals. It melts at 115 degrees C. This low melting point tells us that sulfur has a simple molecular structure. There are relatively weak forces between its molecules. As the molten sulfur is heated more strongly, the rings of the 8 sulfur atoms open up. They then join together to make long chains. Near its boiling point, the long chain starts to break up. They escape from the liquid as a gas. If you pour the molten sulfur into cold water, plastic sulfur is made. The sulfur does not have time to change back into S8 molecules. It is frozen in a long chain structure like rubber. Eventually, the plastic sulfur goes hard. It changes back slowly into S8 molecules again. Here is the diagram that shows how plastic sulfur is made. In the beginning, strong covalent bonds are present there. Weak intermolecular bonds between the molecules are also present there. When it is heated, it is changed into different chains. Then long chains are made on further heating. The chains start shaping and the liquid goes runny again. And when these chains are put into the cold water, plastic sulfur is made. Next, we are going to read the differences between the ionic and covalent substances. Again, very important topic. Ionic compounds are formed when metallic elements on the left-hand side of the periodic table combines with non-metallic elements on the right-hand side of the periodic table. Covalent compounds, atoms of the non-metallic elements combine with each other by sharing pairs of the electrons in their outer shells. A shared pair of the electrons is called a covalent bond. Ionic bonding. Atoms of the metallic elements form positive ions. Elements in the group 1, 2 and 3 of the periodic table forms ions with the charges +1, +2 and +3. For example, Na plus 1, calcium 2 plus, aluminium 3 plus. Elements in the group 7 of the periodic table, nonmetals, form anions. The general symbol is X negative, as each atom gains one electron from a metallic element. Elements in the group 6 of the periodic table, nonmetals, can form, general symbol is Y2- ions, as each atom gains 2 electrons from a metal atom. Whereas covalent bonding is the maximum number of the covalent bonds that an atom can form is equal to the number of the electrons in the outer shell. Often, an atom does not use all of its electrons in covalent bond formation. Next, ionic bonding is there is a strong electrostatic attraction between the ions of the opposite charge. This is what gives ionic solids a close, regular structure. Ionic compounds are crystalline because of this regular structure. The strong force of the attraction between the ions of the opposite charge makes it difficult to separate the ions. This is why ionic compounds have high melting points and high boiling points. Whereas covalent bonding, there are 3 types of the covalent substances. Many covalent substances are composed of small individual molecules. The bonds holding the atoms together are strong, but there are negligible forces of the attraction between the molecules. Such covalent substances are gases, for example, ACl, SO2, CO2, CH4. Other covalent substances consist of small molecules with weak forces of the attraction between the molecules. Such covalent substances are low boiling point liquids, for example, ethanol, formula is C2H5OH, or low melting point solids. The low melting point solids are molecular crystals, for example, iodine. Some covalent substances consist of giant molecules. Atoms may link in chains or sheets, for example, graphite, or in 3-dimensional networks, for example, diamond and quartz. Substances with giant molecular structure have high melting and boiling points. Ionic bonding. Ionic compounds are electrolytes. They conduct electricity when molten or in solution and are split up in the process. Whereas covalent compounds are non-electrolytes. Ionic bonding. Ionic compounds are insoluble in organic solvents, that is, solvents which have covalent bonds. Whereas covalent compounds are soluble in organic solvents, for example, ethanol, tetrachloromethane. Compare this with the giant covalent structures of the diamond, silicon, or sand. To boil these, we have to break apart the whole giant structure. Millions of the covalent bonds do have to break in these examples. So this was the topic. Read it again very carefully. This is very important topic and make your notes. Thank you so much.